This is work led by a community of teachers and youth, including Carlos and Isabel, who were lead undergraduate researchers on this project during the summer of 2024. My name is Amy Coe, and I'm the facilitator of the Wordplay community. We started this project with an observation. Programming languages are a foundational way that people interact with computers, but learning them is hard. They often aren't designed for learning. They're hard to teach because programming is a complex skill that depends on the design of an educational programming language. And they're often used to teach computer science in ways that excludes youth, marginalizing them by their identities. But even when PL are designed for learning, they still exclude. And there's two forms of marginalization that are particularly egregious. One is from language. PL are often English and Western centric, requiring English learning before computer science learning and ignoring the fluidly multilingual, multicultural world. The second is ability. PL are often inaccessible with syntax, tools, and documentation that are not screen readable, ignore neurodiversity, or require fine motor movements like pointing. Prior work has made some progress on these two inequities, but in isolation. For language, platforms like Scratch can be localized to non-English languages, but they can only be used with a mouse or touch. It's impossible to use them with a keyboard, excluding learners who use screen readers. And then on ability, languages like Quorum have been designed to be highly screen readable, but they do this by leaning on English grammar and often only offer English documentation. And so our work with teachers who encountered these challenges led to these questions. Can educational programming languages be designed to be both multilingual and accessible? And what design and engineering and pedagogical challenges arise in designing at this intersection? For example, is it just a matter of web content accessibility guidelines compliance and offering some monolingual localization, or are there deeper tensions between the two? This work started during my sabbatical and has thus far spanned 30 months of community engaged work on PL design and development. These photos show some of the work we're doing with undergraduates, middle school students, and teachers. It's involved partnering with teachers to understand the challenges of teaching multilingual youth and youth with disabilities, engaging multilingual youth and youth with disabilities to understand tensions with existing multilingual and accessible platforms, and consulting with other educational PL designers on how they manage language and accessibility issues. And to evaluate our progress and surface new challenges, we convened a summer focus group of youth and teachers. So we're going to talk about both the results of this work and that evaluation. So these multiple years of effort led to Wordplay, an educational programming language for creating interactive, multilingual, accessible typography. And you can see an example of it here, which is one popular genre with youth, interactive animated song lyrics, such as this animated version of the Radiohead song Airbag. So we don't have time to talk about every aspect of the platform in this short talk, so read the paper or try the platform at wordplay.dev for more details. We'll instead talk about 5 major design choices and then hear what youth and teachers thought about them. The first choice is that output is typographic. Most educational programming languages use graphics, which are inaccessible without image descriptions, and image descriptions are usually monolingual. Wordplay, in contrast, uses text, which can be web accessible and engage culture and identity. Programs can generate multilingual text output, building localization into the PL itself, and text is very low overhead, minimizing internet bandwidth requirements. For example, in this video, a word guessing game can be instantly translated across English, Spanish, and Arabic. Design choice number 2 is that code is symbolic and multilingual. Using keywords in a programming language embeds a particular language in all platforms, usually English, privileging that English and all of its ideas. Wordplay, in contrast, only uses punctuation and multilingual text, allowing youth to embed multiple translations of text strings, names, documentation, and identifiers in code. The editor can then screen read all punctuation for accessibility. The editor can translate code into other languages and render code in one or more languages for multilingual reading. For example, in this video, you can see the word guessing game we just saw and its code. Translations are embedded into not only the game text, but also every variable name, function name, and even its documentation. Design choice number 3 is that code is functional and reactive. Imperative code is verbose and does not explicitly describe its purpose, potentially creating friction and screen reading and language complexity. Wordplay is functional and reactive in contrast, so code is declarative, shorter, and achieves rich interactivity with really minimal code, indirectly benefiting accessibility and language inclusion by reducing syntactic complexity. This example translates the streams of pixels from a camera into typographic grid of colored letter A's with just a few function calls. It's just a few lines of code, and this is partly because of its use of functional patterns, which translates colors into the typographic output of phrases. But it's also because it uses streams, which allow programs to be transformations of data over time by reevaluating a program rather than a complex web of event handlers. Design choice number 4 is that Wordplay has accessible multilingual time travel. Debugging tools are often monolingual and inaccessible to screen readers. Wordplay allows for instant, random access, multilingual, web content accessibility guideline compliant time travel through program evaluation history. This is possible only because of its purely functional nature. It's only necessary to record a history of inputs, and then the rest can be recomputed from those inputs instantaneously. In this example, there's a simple game where a cat chases the letter O, representing a ball. Understanding the collision event is a simple matter of pausing the game, rewinding the collision, and inspecting the frame in which the collision occurred. And finally, design choice number 5 we'll present here is that governance is student and teacher led. This is one of the most important aspects of the project in how we manage power. The project is open source, free, and facilitated by researchers. Teachers and youth set design priorities and curate design feedback. And an undergraduate community of open source contributors help realize the student feedback in a community of peer learning and teaching. This is a picture of one of our partner teachers' 7th grade classrooms. An undergraduate is talking about the project's design process, encouraging students using the platform to share bugs and feature ideas and help shape the project's priorities around their interests and learning goals. These and other design choices are not necessarily good design choices. To evaluate them, Carlos and Isabel, undergraduate community members, convened a focus group of 2 teachers, 3 middle school students, and 1 undergraduate to examine the platform's design trade-offs. We held 5 sessions asking the group to examine wordplay relative to other educational programming languages and using the design principles that emerged from our design process. There were 7 principles from the community, and we structured the sessions around these 7. The community believed educational PL should be accessible, liberatory, transparent, cultural, obtainable, democratic, and enduring, all shaping a larger vision of justice-centered educational programming language design. The focus group critiques then led to several different outcomes. One, that they broadly affirmed the goals of being web-based, screen-readable, usable offline, broadly multilingual, but also noted several gaps in Wordplay's multilingual accessibility. This included issues around internet access, speed on smartphones, customizability for access needs and neurodiversity needs, more diverse youth governance, and multiple different ways of learning the programming language and framing youth as shaping the future of computing. We also noted several tensions between accessibility and language when engineering the platform. It turns out that trying to do both of these at the same time makes PL more complex to build, learn, configure, use, and teach. For example, if everything has a description for accessibility purposes, then everything must have thousands of descriptions for every language and reading level supported. And focusing on text, while it increases accessibility and language inclusivity for interactive typography, often does so at the expense of other kinds of cultural identity, music and imagery and other things that youth wanted to create with. We also found balancing power through youth governance of an open source project raised a lot of tensions between self-efficacy and our own expertise. And so it is possible to build an accessible multilingual educational PL, but it does surface real tensions. We have shown that everything required to overcome these tensions, diverse, sustainable governance, engineering agility, often requires resources that educational programming language communities just don't have. We're excited to continue exploring ways of trying to achieve these broader questions of justice-centered educational programming language design and finding ways for all youth to participate in shaping the future of computing. Thanks.